Welcome GeoTrig. This is 9.6 and 9.7, Dilations and Similarity. The essential question is compare and contrast PlayStation 4 and Xbox One. Let's begin. So I kind of cut this section a little short. I'm just going to go over the highlights of what I think is important. The first thing is about dilations. It's basically scaling up figures. So you have to scale up the figures, you have to have a center of dilation, and that's some point that's like the basis of where you're scaling up on. And then you have to have a scale factor. It's kind of like the ratios of when we were talking about similar triangles. So in this case, when you have your point and you have your figure and your scale factor, you can scale up your figure. And this diagram kind of shows what's going on there. But basically, you need that point and you need to know how much you're scaling it up. So here's an example of this case. It's not just simply scaling up the figure. It is knowing where you're starting it from. So we got the original shapes, this black parallelogram here, A, B, C, D. And the scaled up figure is this A prime, B prime, C prime, D prime. You notice that right here the center is at A because this is the corner that's staying the same. And it basically just grew out from that. And the scale factor is 2 because this original side CD is 2. But you multiplied it by 2 and now this side is 4. So everything doubled in size. In this case, for this trapezoid here, C is our center right here, so it all shrunk in this case. And every corner just kind of came in, and C is at the center. And the scale factor in this case, when you're going from 8 to 2, the scale factor would be you're dividing by 4, so it's going to be 1/4 scale factor. So I kind of looked at like what I usually do on here when I have shapes. This thing scales it up and down, and you notice that like where's the scale factor, and the scale factor is actually at that corner. So it's not just you're growing it arbitrarily. You have to have a center that you're scaling it from, and then that kind of tells you where your shape's going. Similarity and transformations. So shapes can be similar. Shapes are similar when there's a combination of rigid motions and dilation that can create them. So any amount of rigid motions, or even known rigid motions and dilations, will create that figure. So this original figure would be the black one here, DEF. And then what it looks like they did here to get the red figure is they mirrored it on the y-axis. So that gives you the red figure. And then it was scaled up from the origin. It looks like everything was multiplied probably by I don't know what it was multiplied by, but I think it was scaled up from the origin, and you got the new one, F double prime, E double prime, D double prime. So all these triangles here are similar with each other. They're just a combination of rigid motions and dilations. That's it. You can figure this out. Let's do some examples. Go. Alright, our center dilation's at the origin, O. Scale factor is 2. What are the new vertices? So we got Z, G, and P right here. So if my scale factor is 2, basically these are all going to double in size. So this side here, ZP, is going to double. That means we're going to go another, like half that length is about this length. That should go out to about here, and that's going to be our Z prime. P, following that same slope, this chunk, we're going to have another one. P should be right here, and this will be P prime. G is going to double. Instead of being 2 spaces down, we're now going to be 4 spaces down. And that's going to be, let's say that line goes through, and this is going to be G prime. So our new shape looks like this. And this is a similar triangle. So in our case of the new vertices, Z prime is going to be at -4, 2. P prime is going to be at 4, -2. And G prime is going to be at 0, 1, 2, 3, 4, -4. Alright, next one. Pause the video. Okay, this is neat. Is there a similarity transformation in the maps of these two triangles, JKL and RST? If so, identify similarity, and if not, explain. So basically, are these triangles similar? And we kind of did that the last chapter anyways. I look at to make sure that the smallest sides match up. So 10 and 12 have to match up. And actually, we can just treat this like all ratios last time. So 10 and this 12 have to match up. And then the middle ones, this 12 and this 16, have to be the same ratio, 12 over 16. And then the last one, 16 over 20, has to be the same ratio. So 10 over 12 is 5 over 6. No, these aren't going to be the same ratio at all. So are these similar? No, because the sides don't match up. They don't scale the same way. They don't have the same scale factor. That's it.